So this is the section number two for the third chapter. It's the graph of a function. In this section, we're going to be analyzing the different all the concepts about the graph of a function. We're going to go over the concepts like um, domain of a function, the range of a function, intercepts, maximum, minimum. We're going to look at even and odd functions, and we're going to uh, look at when a function is increasing, a function is decreasing, and all that good stuff. So let's get started here with the graph of a function. So in this example here, we will determine the function's domain, range, x-intercept, and y-intercept, if any. We would use interval notation for the answers. And also, if an element is asked to be found and you don't have it, this element does not exist, you can just put DNE, and I believe that you can also type DNE in caps in my MATLAB, my open math as well. So we're looking at this graph here. The first things that we need to find are the domain and the range. Now, the concept of domain and range are the all the x values. Remember, we talked about that in lesson 2.3.1. Domain is all the x values that the graph of the function covers. And the range will be all the y values that can be counted as output for the function. Now, I said can be counted, and we can do the same thing for the domain as well. Now, I'm looking at this graph. Obviously, this graph does not stop at the edges of this coordinate system or this grid. The graph does not stop at this point here. It continues. You can see the trend, how it keeps going up, but also leaning toward the left as it's going up, and also leaning toward the right. It doesn't go up straight. Now imagine this graph going up all the way and continues to lean toward the negative numbers on the left and continues to lean toward the positive numbers on the right. You would clearly see that we will never imagine a number, no matter how small it is on the left, no matter how big it is on the right, not to be covered by this graph, right? It goes forever to the left as it goes up, and it goes forever to the right as it also goes all the way up to the right. So we can tell that okay, let's start with the x-intercept and the y-intercept. X-intercepts are, or y-intercept, let's start with that since that's the first question we want to ask. So two things that we want to determine. We're going to determine the y value at which we can see an x-intercept. The x-intercept is always an ordered pair, because you see how every element in this grid can be seen as an ordered pair. There's an x component and a y component. So whenever you are looking for the x-intercept, the or the y-intercept, the y value is given. Also, you can give this element in ordered pair. So here the y value is 3, and the ordered pair that represents this y-intercept is 0 for x and 3 for y, since it's exactly on the y-axis. Same thing for the x-intercept, or if we have multiple, we have a connection with the x-axis here and a connection with the y-axis here. So that means we have two x-intercepts. So the values are 1 and 3. So the ordered pairs are x equals 1, y equals 0, and x equals 3, y equals 0. We started the conversation about domain and range. Now we're going to see how far this graph extends from left to right. We already saw that this goes forever to the left and forever to the right. So the domain will be starting from left, negative infinity, and to the right, positive infinity. The range, now we're looking at how it goes from the bottom up. Now, obviously, if we consider this from the bottom up, I'm going to use this to show you. So I'm going to try to go from the bottom up here. See, I'm going from the bottom. I'm moving here. I'm not touching any part of the curve yet. So all of these values here will not have any x values that would give you these outputs, because they don't have, the graph does not go all the way down here. And then that's where I start to see part of the graph. That means when I get here, I can tell that there should be an x value that will give me a y that corresponds to -1. And then from that point on, I can go up all the way, and then we will always continue to find values. So basically what I'm trying to show you here is I'm showing you anything lower than -1 on the y will not have a input for it. The inputs are x. We need to remember here the x values are the inputs, and then the y values are the output. So the output, the y values that are lower than -1 will not have an input for them. So they're not in the range, since they don't have any input corresponding to them. When you start getting to -1, you see x equals negative, y equals -1, then there will be an x for it, right? There's a point here, so the x will be 2, and then so on. You will always have, since the graph is continuous, you will always have at least one x for any y bigger than -1. So from -1, and we're going to include -1 because the line is on it, and then it's not, say, there's no restriction as if it was an open circle. So there's no open circle. You need to keep in mind, when you don't see on the graph, if you don't see an open circle, that means the value is included for x and y. So here we're working with the y, so that's -1 to infinity. All these values are we will be able to find an input for all the y values from -1 to positive infinity and up. Okay, so that was the three elements that we needed, the four elements that we needed to find: the x-intercept, the y-intercept, the domain, and the range of this graph. So we analyze it, and we see that the domain was negative infinity to positive infinity. The range was from 1 all the way up to positive infinity, and the x-intercept and the y-intercept are where the line crosses the x and or the y-axis. Let's move on to the next example. It's the same thing that we're looking for. We're looking for the domain, the y-intercept, the x-intercept, and let's get started. So here, what's the domain? We do the same thing here. So we're gonna try to read this from the bottom up, from left to right for the domain. Okay, now I'm going from left. You see, going from left, nothing, 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 and then boom, we start getting some values here, and we see that this is a closed circle here. So on the left of -1, there's nothing. So that means for the domain, we have no values included. No input will be included from, lowered, no input lower than -1. So that's -1 is the starting point on the left, and it starts with a closed circle. So we're gonna put a bracket always for closed circle, bracket -1, and now we're going to see how far on the left it goes. How far? So let me keep moving from -1. I'm moving all the way through. You see, as long as I'm moving and I am on the blue line somewhere, then I'm good. I can keep moving. 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 Boom, no more. No more blue. And then the value at which I stop is +3. So I stop at +3. But because it's an open circle, the -3 opened, so I'm gonna need to keep a parenthesis on this value. Now we're going to do the bottom up, which will be the range of the graph. So now I'm going to look at the bottom up. So from the bottom here, you see that's an open circle here at -5. So y equals -5, right? Y equals -5. I start here from the bottom, -5. So that is open circle, so -5. And then I'm gonna start moving up, going up until I can't be on the line anymore. Moving up, you see, I can still be on the line. I can still be on the line. You see on 5 here, nothing, but 4 is the last point on the Y that I found. 4 here, so I'm gonna keep 4, but we did not see an open circle on 4, so this is gonna be a bracket. Okay, and then let's look for intercepts. Intercepts, as you know, are when the line, the graph intersects the y, will be the y-intercept. When the graph intersects the x, will be the x-intercept. So let's start with the x-intercept first. Where do you see the line crosses the x-axis? It's this. And again, I'm reminding you that it's not just one value. It's a point of the grid that is the intercept. But it's always going to be, if it's on the one axis, the other axis will be a 0 for it. So if it's on the x-axis, the y is 0. If it's on the y-axis, the x is 0. In this case, we're looking for the x, then the y would be 0. So the value of x is 2. The value of x is 2. The y-intercept would be, the x-intercept, sorry, would be x equals 2, y equals 0, with the x value equals 2. And then the y-intercept, we're looking for it. That's where we touch the y-axis. So the y-intercept will be x equals 0, y equals 4, with a y value that is 4. Let's go to the next example here. We're going to do the same analysis for this one. See, it goes all the way up, and so Let's look for the y-intercept. Y-intercept is x, y value is 5 for a ordered pair. For an ordered pair that is x equals 0, y equals 5, and then the x-intercept. See, that's the x-axis. The line is above it, and it never goes on it. So then we would have this does not exist. The domain, as it opens up as it goes up. So that means the domain will be from negative infinity to positive infinity. And the range, we look at where it starts from the bottom, that's 4, with a bracket, and it goes all the way up to infinity. And now they ask me to evaluate when x equals this. The meaning of this is to evaluate this, meaning that you need to find the y value when x equals -3. That's the meaning of f of -3. F is given to you. That means it describes how the outputs are given for each y. It gives you all the ordered pairs, but if it's a continuous function, so you would always have from one point to another point, always have, no matter what the value is, you will always have an output for a given input. Now, when they say f of -3, they say, oh, okay, well, let me give you this input. What would be the output? And the output will be the f of that value. Output for -3 is f of -3. Output for 0 is f of 0. And then the f of blah, blah, blah are going to be the y values. Okay? Hopefully that makes sense, because when you see f of, don't only think plugin. You need to think it as the concept describes it. Concept of function is a set of ordered pairs. A set of ordered pairs, that means if I have a y, if I have an input, there would be an output. So if I have the output, then there will be an input for it. They can give you the equation, they can give you the table, just like we described in our first topic. Now let's go ahead and find that f of 3. So x equals f of -3. X equals -3. Let's look at this on the grid. That's -3 here. Now, how many steps should we take up or down to find to touch the graph from -3, right? So if you take steps, the number of steps up, meaning that the y equals positive, that value. The number of steps down would be y, f of -3 determines the number of step down, meaning that it's negative. But obviously in this case, you cannot go down and expect to touch that line, that graph, right? Because it's all the way above the x and never goes down. So that's why for me, from -3, if I want to touch the line, the graph, I need to go up. So let's see, we will go up. That's 1, 2, 3, 4, 5, 6. So that means to get f of -3, I need to go up 6 times. So f of -3 equals 6. Let's find f of 0. That means x equals 0. That's my x equals 0 here. Let me see how many steps up I should take to get to the graph. Obviously, if I take 1, 2, 3, 4, 5, I would touch the graph. So f of 0 equals 5. So f of is the output, and the number in parentheses, as you say, f of that number is the x value. So f of x, meaning input equals x, output is f of x or y. Okay, so let's move on to the next example. In this example, we're going to be talking about maximum and minimum. Maximum and minimum of a function. Now we need to make sure that when you're talking about maximum and minimum of a function, we understand what we're talking about. And we understand also how to read a graph. The reading of a graph is always from left to right. Now, let's say I'm putting my finger over here and I'm trying to follow the line along. I'm going through the line as I'm moving. So you would understand that if I'm moving like that, you all think that I'm going up, going up, going up, going up, going up, going up, going up. Stop. So stop. That's a turning point. And if you pay attention, you would see you have multiple turning points in this. But what I want you to see here is that I am going up from left to right. If the graph started up here, then I would start it from the left, always from the left if it was here. And then for me to follow, if it goes down, then I would call this one decreasing. But over here, we had to increase because we were going up, increase. Now, when you look at this part here, going down, going down, going down, we decreased. So that is decreasing. And then we can continue to see more. Well, we're not going to forget that this is another turning point, right? This is another turning point here. I'm going to put T for turning point. That's a turning point here. And then from there, we can also go up and up, 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 another turning point. That's another turning point. And then from that, we can also go down, 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 all the way to the last end of the graph. So we have this is increase, and then also that is decrease. So in a graph, you can have multiple pieces where moving up, moving down, moving up, moving down. Now, the thing that we're trying to see here, later on, we'll talk about increasing, decreasing intervals. But now what we're looking at is the turning points. The turning points can be maximum or minimum. Or let's call them relative max, relative mean. So the relative maximum are when the graph, let me put them here, relative maximum These are the turning point at which the graph stops increasing to decrease. To start decreasing. So if I have a turning point where the graph stops increasing to decrease, then that's a maximum. So that's a relative maximum. That's a relative maximum. So we can tell that this is a relative maximum, and then this also is a relative maximum, because you can see you go from a increase to decrease. That's why it's a relative max. Here we go from an increase to decrease. It's a relative maximum. Now let's see what is a minimum. A minimum, relative minimum, would be a turning point at which the graph stops decreasing to start increasing. So now, increasing and decreasing, you see movement in that, right? Movement. But the point at which you have this transition is either a maximum or a minimum. And if you want to call them in general, you call them an extremum. An extremum is either a maximum or a minimum. And if you have multiple extremum, they are called extrema. So the plural of extremum so if you have multiple turnings, you just call them extremum. I mean extrema, because if you would have multiple turning points. Now that you understand this, we can go ahead and tell what are the x values and the y values, because anytime you see a point, remember, and that's what we were talking about earlier when we said that the intercepts are points in the coordinate system. So remember, I told you that the maximum, relative maximum, and relative minimum are the turning points, they are points. So there will be X and Y values for each of them. Now, since you understand this, I'm going to clear this so you can see the points. And then we would be able to determine the answers. So here, let's work with those two. This and that, they are what we called relative maxima, because we have multiple of them. But what are the X values for each? So we got one here that goes to an X value that's -2. And then the second one stays at located at X equals located as at 0. It's located at 0, at X equals 0. Okay. Now that's that's maximum. And what are the Y values, or what is the Y value? Well, both of them, they are located at the same height in the coordinate system. That means Y, there wasn't anyone taller than other. So they stay at the same height, and that means they have the same Y value, which is +3. Okay. And then now let's talk about minimum. Minimum would be the only turning from going from decreasing to increase is that one here. So that's the only minimum, relative minimum we have. What's the X value for it? The X value is -1, and the Y value is -2. Okay. Let's do more. Well, remember earlier we were talking about decreasing and increasing. So the three elements that are involved in this concept of increasing and decreasing, or variation of the function. So three concepts involving in the variation of a function are increasing, number one, increasing interval, number two, decreasing, and number three, constant. Okay, now increasing will be when the function have a positive slope. So you see the slope of the graph, well, that's going up, right? I showed you that earlier, how the increasing portion of the graph is when the graph is going up. But you would see in terms of slope of the graph, even if it's not a line, but if I give you this, if I give you something like this, you can see the trend of the line. From left to right, you can tell it's not a straight line, but it's uphill. So that's why you can still mention the slope the global slope of this curving line is still a positive slope. So that's exactly why I'm talking about the slope. It will not be seen as the slope of the straight line, but the trend is positive because it goes up. That's what I'm talking about. So you can tell that you have to go up from left to right. Or if I take a line like this, it's not straight, but you see that the trend is that it's going down. And if I give you a line like this, well, most of the time you would say, oh, okay, well, that is a slope 0 because it's a horizontal line. So you would tell that the slope, and then that's we would use this slope concept to identify parts of a graph that is increasing, decreasing, or constant. Now, remember, we're looking for, if they ask me to 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 give the precision on the interval, they're trying to talk about the x values. It means give me the x value at which the graph starts. The graph starts to go to increase to the point it stops. That can be a turning point, but that may not be a turning point. But you can tell when it's going up, when it's going down, that when it starts to go up, and when it stops going up to do something else. So in summary, what are we saying? We are saying that a function is increasing when the slope is positive. The function is decreasing when the slope is negative. And if a slope is 0, the function is constant. Now, when I say slope, you need to think of the trend going up, going down, or horizontal. Let's look at this one to see what are we saying. And then whenever you see something like that, you need to think of something that goes indefinite. Now, we are looking for the open interval. Well, keep in mind that you always use, let me put that here, always use parentheses to give interval increasing, decreasing, and constant interval. Always remember that. Okay. So now remember this keeps going. So that's negative infinity for x. That's negative infinity. Remember, when they ask you to give the interval, increasing interval, they're asking you to tell from what x value to what x value the function is increasing. So let me show this as it's going up. Okay, it goes from left to right. But here, I can tell from negative infinity to this value right here, or we're not even here, to this value here, which is -4, this graph is going up, right? So the increasing interval will be from negative infinity to -4, remember, always use parentheses for when you're giving decreasing, increasing, and constant intervals. Do you see where the graph is now decreasing? Well, I see no part of this graph where it's decreasing. So that's DNA. And constant, it goes from -4 and all the way to positive infinity. Let's do the same thing here, but I'm going to add a few more things in that one. So we're looking for the domain, the range, the x-intercept, and then more of interval notation. But also, I want to talk about, in this example, when the function is positive and negative. Well, increasing and decreasing are not positive and negative. You have to make sure you understand that. Function is positive when the graph, or when its graph is above the x-axis. So what you're going to do here, if they ask you to say to give the interval where the function is positive, now you're looking for all the x values for which this graph is located below positive, above the x-axis. So positive means above the x-axis. Negative means below the x-axis. Equals 0 means on the x-axis. Now, if they say greater or equal to 0, you're going to take all the parts of the graph that are above the x-axis, including the value at which it touches the x-axis. So that's when you're using a bracket. Remember, use bracket when you have that on the value. But if you have just that or that, so you're going to use only parentheses, right? So I wanted to mention this. So above the x-axis is f of x, f of x, f of x greater than 0. Function is negative when the when its graph, I put V here, so I should remove it. When its graph is below the x-axis. So that's when you say f of x less than 0. And then function is equal 0 when its graph is on the x-axis. So you have f of x equals 0. Well, you understand, if I have equal, less than or equal, then I just include the value. So let's start with the domain here. From left to right, I can tell that the domain is from negative infinity to 8. It's just read it from 0 from left to right, and this is a closed, so I put a bracket on 8. The range from the bottom, negative infinity, and then up. Up is 9, right? That's y equals 9 and include 9. X-intercept. The x-intercept would be where the graph touches the x-axis. So that is x equals 2, y equals 0. Increasing interval. Now, when you look for the increasing interval, it's important to identify your turning point, because your turning point will determine the point at which it stops. It may start again, but it will stop at a turning point to do something else. Either stay constant or decrease if it was increasing. If it was decreasing at a turning point, it will stop to do something else. If it was decreasing, then it will stop to stay constant or to increase, to reverse the action or to do something else. So that's why you look for your turning point to identify your x values at which the beginning action ends to start something else. So the beginning action here is what? So I'm looking at this piece on on the left and below the x. Well, on the bottom left. If it's on the bottom left, that means this graph, if I'm scrolling through it, I'm going to have to go up, right? Because if I follow this, the slope too, like the slope is positive, right? So because the slope is positive, from negative infinity, from increasing, is from negative infinity to where the turning point is at. It's 4. X equals 4. That's the turning point. So 4, and we always keep parentheses for increasing, decreasing, and constant. Now, what did it do after the turning point? After the turning point, it starts going down. So at 4, it starts going down, and it actually stops at x equals 8. So x equals 8. And you always keep parentheses. There was no point at which this graph was constant, meaning having a constant, having a zero slope. So I would say D&E for this one. Now let's identify point interval for which this graph is positive. Well, positive mean what? Mean below the x-axis. Well, I see that it's below the x-axis for all the x values that are from negative infinity to 2, because that's 2 is the transition from being above, from being below to above. And the 2 is where it equals 0. Where is it greater than 0? Well, it will be greater than 0 for all the other points where I see that it's above the x-axis. It's from 2 all the way through 8. 2 all the way through 8. See, all these points are above the x-axis. And if I take the x values, you see, it goes from 2, it covers the x-axis from 2 to 8. That's the f of x greater than 0. And then this one continues. We're not going to forget that. And then all this would be over here, starting from negative infinity. And then here, all these will be below the x-axis. So that's f of x, that's f of x less than 0. Okay. Now what else they want me to find? They want me to find the x value. They want me to find the x value for which this function has a relative minimum. Well, I have no turning point when the graph stops going down to go up. That's minimum, right? Remember, minimum is when you have a graph that minimum here is turning point at which the graph stops decreasing to increase. We did not stop decreasing to increase. We stopped increasing. We stopped increasing. We stopped increasing to decrease. So we don't have minimum. We only have a max, right? We have a maximum. So this is DNE. Oh. The value of the minimum also DNE, because that would be the Y. So whenever they say the value of any minimum, that's the Y value at which the graph stops going up, down to stop decreasing to increase the Y value. So that would be the value of the minimum, which would be the Y. We don't have that. So let's look at for the relative maximum. Well, we did have that, right? There is a point here where we stopped going up to go down. Then the X value here would be 4. The X value for which we have a maximum. So X equals 4. And what was the Y value here? That was 9. The value of this would be the Y. So Y equals 9. They want me to find f of 2. F of 2. What is x equals 2? That's x equals 2. Oh, it's x equals 2. So let's see how many steps we would go up. 1, 2, 3, 4, 5, 6, 7, 8. 8. So f of 2 equals 8. And then the x value for which f of x equals 9. So y equals 9. We already have y equals 9. That means x equals 4 here. So let me check on the graph. Y equals 9 here. We touch the graph. See how many steps you would go over to see what x it is. So one step, 2 step, 3 steps, 4. So we took 4 steps from y equals 9 to see what x would correspond to it. So x equals 4. Now to answer this question, we do want to answer the question about whether the function is even, odd, or neither. We want to go over this concept. When is the function odd? When is the function even? When is it odd? So let's go to here. where I go over these notions here. Now we talk about here, we talk about even functions and odd function. Now, there are two ways to see this, right? We can see it by looking at the graph of the function, but if they give me the equation of the function as f of x, then I also can see when my function is even or odd. Now, here's how to identify based on the graph of the function, right? Well, if it's the equation. So if they give me an equation for the function, the way I would identify it as even, I need to make sure that when I plug in f of x, the result I get out, it doesn't change my equation. It doesn't change my function. Let's say, for example, I take f of x equals x squared plus 1, right? I take this function here. Now, I want to know whether it's even or odd. What I do is I'm going to replace x by negative x. If f of negative x is the same, right? They equal, is the same as f of x, then I say, oh, okay, this function is even. Let me see. So we're going to calculate f of negative x, right? So that would be negative x squared plus 1. Well, negative x squared is negative x times negative x, which is, this will be plus x squared. So we see that that is x squared plus 1. Well, plugging in negative x did not change the function. So that means negative values and positive value, if you have the same value, you would have the same y value. So x and negative x, they have the same y value. This function is even. This function is even when x and negative x have the same output. When x and negative x have the same output, the function is even. Or when f of x equals f of negative x equals f of x, the function is even. Let's see here an example on the graph. I'll show you this bigger. That's negative x, right? I mean negative 2. X equals negative 2, but negative x. And then that's positive x. Let's see. Well, the y value for this one is 4. Also, the y value for negative 2 is 4, right? So that makes this an even function. Oops. That makes this an even function. Because f of negative 2 is the same as f of positive 2, but it's not only for 2, not only for 2, it works for any value. You want to check for negative 1 and positive 1? You want to check for negative? If the function, you continue to look at it, it would still be that. So what I'm trying to show you here is that even functions are functions that have the same y value for both x and negative x. Same y for both x and negative x. The function is even. Now you can see it on the graph if they give you the graph, or you can see it on the using the equation by plugging in negative x every time you see x and do the math and find the result out to see if, and compare it with what the function was actually before you plugged in. If they are the same, the function is even. If they're not the same, it may be the opposite. Then you will talk about the odd function. So now let's talk about when the function is odd. A function is odd when plugging in f of x, plugging in x, negative x into f of x is the same as multiplying f of x by negative 1. When you input negative x, it's like multiplying f of x by negative 1. Here's an example. Take f of x equals negative x cubed. Let me put x cubed minus 1 minus 3. Now what? Plus 3 minus 3. Let me just take x cubed. So we're gonna try to find f of negative x. So that means it's going to be negative x to the third, right? So that means what? That's negative x times negative x times negative x, right? Which is, that's positive x squared, right? X, and then the negative goes out now to the third. What is that? That was f of x. So basically, x cubed was f of x, right? So that means I just found that f of negative x is negative f of x, right? Because this is just f of x, and that negative sign here makes it negative f of x. So what do we just say here is that we're showing you that a function is even function, or functions where x and f of x have the same output. I mean, x and negative x have the same output. And an odd function is a function where x and negative x have the opposite output. Like the output of x is the opposite of the output. So now we can go back and do this example over that we were working on. So looking at this graph, clearly we can tell that this is not even. I'm going to show you why. Well, I mean, if you take this example here, let me clear the graph so we can see better. So, well, for some values we can tell, but like not all of them. Well, not even one. So let's pick an x random, because if we want to know whether it's even or odd, every x and their negative should be able to give me the same y if the function is even. And if it's odd, every x and their negative should have opposite y. That's pretty much what is it. Just like this one here. See, if I take x equals, I don't know, just take x equals 1, right? X equals negative 1, x equals 1, y equals 1, x equals negative 1, y equals negative 1. So f of x is negative f of negative x. So let me write it differently. F of negative x is negative f of x. So if we pick an x one value that doesn't verify it, then you automatically disqualify it to be even, disqualify it to be odd, and if it's not odd, not even, it will be neither. Okay, so here let's look at the graph again. Let's take x. Well, I can take any x to check. It's checking. So x equals 2. What is f of 2? F of 2 equals 8. Now, if it's even, that should be the same. Even would mean even would mean that f of negative 2 equals 8. Odd would mean that f of negative 2 equals negative 8. Let's see, f of negative 2. F of negative 2 is 0. So this function is neither even nor odd. Next example. So in this next example, we are continuing this search of increasing, decreasing intervals, and well, that's just it for this example. Now, since for this one we started up here, and then to follow, you would have decreasing and from negative infinity. Well, we need to remember that this goes forever and this also goes forever. So we have a decreasing interval from negative infinity. As you can see, it continues up, but with a trend toward left on the x-axis. So it goes all the way to negative infinity, and then that's the location x equals negative 4, where it transition from going down to now going up, and then it stops going up. It stops going up here at x equals negative 2 and it stays constant. It stays constant from negative 2 to 1, starts going down again from 1 to 2. Well, see the x is 2, and then continues back constant indefinitely. So basically we see that the increasing, we're looking for first, and we're gonna forget that join the interval with a union sign. So interval, increasing interval. Increasing interval is the part that is in green only, that starts from negative 4 to negative 2. That's the increasing. We need the decreasing interval, that is from negative infinity, x equals negative infinity, all the way to negative 4. Also picks up again from 1 to 2. So that is the decreasing interval. And the interval where the function is going to be, so that's decreasing. And then constant will be where its constant is from negative 2 to 1, and picks up again at 2 to infinity. We are also asked to find the domain of this function. Obviously, on the left, it goes forever. On the right, it goes forever. So that means our range is going to be from negative, and our domain is going to be from negative infinity to positive infinity. And then our range would be how far it goes from the bottom up. We have nothing past. Let me show that. We have no parts of the graph below x equals -3. So it starts from -3 bracket because it's included, and then it goes all the way up to positive infinity. See the arrow, it goes up, never stops. So that's positive infinity. Next example. We already talked about when you have an even function. So now all we need to do is to verify whether this function is even or odd. Here's the function we have. So what I'm going to try to do is I'm going to find an x value. Well, the one that's more noticeable is this value here that will be halfway through one from 0 to 1. So let me call this x equals 1/2. So over here, I would look for the negative x. The negative x will be -1/2, right? It's this. All right, so now I'm looking at this. So we got f of x, or 1/2, equals 4. And then we also have f of 1/2. Well, for any point, it would give me the same thing. I'm not going to check it only for that. I just pick that one because this one is more noticeable. But any number I would take on the x would be able to give me that. Say, for example, if I took x equals 1, f of 1 would be 5, and then -1, which will be negative x, is -5, right? So any x will give me the same result that I'm trying to see with x equals 1, -1/2 or +1/2. So f of -1/2 is -4. So basically, I found f of -1/2, which is -4, is the same as negative f of x, a negative f of 2, 1/2, negative f of 1/2. Now, what did I just check here? I checked that for x equals -2, f of -2 is the opposite of f of 2, which corresponds to f of x equals f of negative x equals negative f of x. That's a function that is odd. That's for a function that is odd. And if you checked for 1, it would give you the same thing, -1. It would give you the same thing. Now, you can see also how the shapes are, and they are on both sides of the y-axis, and the shapes are identical, and the y-axis is the separation, and they are also symmetric with respect to the x-axis. Symmetric with respect to the x-axis. So that also gives you the sense how you get they are symmetric to the origin, not to the x-axis. They are symmetric with the origin. So that gives you the sense how this function is an odd function. I can even add here that odd functions, they are symmetric with respect to the origin. And here, symmetric with respect to the y-axis. Okay, let's try another one here. Same question here. We're looking to see if this function is even or odd. Even function, remember, they are symmetric to with respect to the y-axis. We also know f of negative x equals f of x for functions that are even, and odd functions, they are symmetric with respect to the origin, and then f of negative x is negative f of x for any x value in the domain of the function. Now, if we cannot have even or odd, we just call it neither. So in this case, this one answer was A. And now we're doing the same thing. Let me pick an x value, because if it doesn't work for one of them, we're done. If it works for one, we need to make sure that it would verify for anything before we make the conclusion. For everything, any number you pick, if you pick an x and you have a value for the result for the y, then you need to look at the negative x. What is it? If it's negative, the result you get for the other one, then it's odd. If it's the same, then it's going to be even. Now let me pick an x value. I'm gonna choose something that I can really find. So let me pick 1. So f of 1 equals 5. Let me find negative 1. Negative 1 is this, f of negative 1. F of negative 1 is 3. Well, 3 is not 5 or negative 5, which would make, if it was 5, function was going to be even. If it was negative 5, then that would, well, it would help me decide whether it's even. If it was 5, same as f of 1, if f of negative 1 was the same as f of 1, that would make me closer to making my conclusion that it's an even. Not only one number, we would make sure that we follow the pattern. If any negative number, if any x value would give me the same result as 1, gives me for a negative 1. But if it's different, then we had nothing to decide. So if it was 5, that would take me closer to deciding that maybe I need to look deeper in order to decide whether it's an even or not. But it's not 5, so cool, it's not even. Clear? We clear on that. And then if it was negative 5, I would be closer to deciding whether it's odd or not. But it's not negative 5. So conclusion now, it's not odd nor even, so it's neither. Let's go to next example here. We'll trying to see whether it's even or odd. So pick an x equals 1, and then -1. Well, now I can see both of them give me 5. So we have f of 1 equals f of 2, f of -1, that meant. Well, that's not enough, right? I need to make sure that, how would it be here? So I see if I take anything in between, that would give me the same thing here, as long as I measure them right. So I see clearly that this is the pattern of an even function. Let's try this one as well. For this one, we're going to decide whether it's even, odd, neither, and then we will indicate whether we have a symmetry with respect to which axis, or symmetric would be the same distance from which axis or origin. So, since I see 4 and -4 are very noticeable. So let me see what is it for -4. -4 is, both of them will give me 1 as their y. So I see that f of 4 is, if f of -4 is the same as f of 4. And then, I can see the pattern here, how it goes for any value. I would expect the same y. Any x value, I would expect the same for the negative number. So that's the pattern of an even function. The same value for the positive and the negative number. That's A. And then now symmetry, right? And when you take any number, the distance from the distance would be the same from either the origin or the y-axis. It's the two elements you have are symmetric with respect to the x or to the y, or symmetric with respect to the origin. Those two symmetrics we talked about, elements of symmetry. So what do you see here? Let's take some numbers. Well, first, when we take 4 and -4, distance from the y is the same from distance from the y for x equals 4. But the reason we can't tell that it's symmetric to the with respect to the origin is because that's the origin here. If I take f of x, and if I take x equals 4, x equals -4, the distance from 0 is the same, but it's not on the opposite way, right? So that's the distance from the y-axis that we count now, because we need to expect it in the opposite way. So it would be the value f of x, f of 4 should have been found somewhere down here. It's not that. So that's automatically. And remember too, we didn't even have to do that, because if the function is even, then you automatically know that you have a symmetry with respect to the y. Even function. Remember? Even function have a symmetry with respect to the y. And odd function have a symmetry with respect to the origin. So then, yes, we have a symmetry with respect to the origin here. So that's A. We're looking at this. Now, first, we want to know whether it's even function. So that's going to be the square root function. The square root function. We're going to take an example. Let me take 4, right? -4 doesn't even have something for it. So that makes this not even, right? Because you would have expected something, you would have expected something here for 4 in order to say that you have even function, or you would have expected something down here. Something down here in order to think about odd function. So we don't have neither of it. So that's going to be a function that is neither even nor odd. Okay, here's another example, and that's, by the way, this is the square root function. So f of x equals square root of x. This is the reciprocal function. The reciprocal function is f of x equals 1 over x. So that its graph, let's see here. Let me take one. F of 1 is 1, and we take -1. F of -1 is -1. So that means f of -1 equals -1, which is negative f of 1, right? Because f of 1 equals 1. F of 1 equals 1. So we get the fact that we see this, then we find that f is odd. F is odd. Well, obviously that's not enough, but at least you see that if you were to take 2, for example, then you would find something similar. That's 1/2, and then x equals -2. You see, it would be -1/2 as well. And any number would have given you the same thing if you follow the pattern. And you can see the curves on both sides, they reflect the same way. They have the symmetry. Okay, so then that's why you would say that this function is odd. Well, you would see the shape and then test it with 1 or 2 numbers to see whether your guess or intuition would be applicable in the situation. But in this case, it works. And also, it's because it's odd, you expect a symmetry with respect to the origin. This is the absolute value function. F of x would be equal to absolute value x. And then if you already see the shape, symmetry with respect to the y. And then if you take a value here, f of 2 equals 2, and f of -2 would be the same too. So f of -x equals f of x for any x value. So we say that this function is even. Well, same thing here. If I take this, f of 2 equals 4. And by the way, that's a quadratic function. F of x equals x squared. That's the quadratic function. And then that's f of 2 equals 4. F of -2 would be the same thing. And you see the pattern, right? So we would conclude that this is even. Let's check this one. This gives me the sense of something that's going to be odd. Let's see. First, that's identity function. So that's f of x equals x. So let me take anything, 3. F of 3 is 3. -3. -3 is -3, right? So we got f of, well, we check it with this, but in general, that's what you're going to be finding for any x. So f of -x is negative f of x. So that's an odd function. So, but not testing this, and then what you would be your intuition? well, that will be odd because you see how the symmetry is with respect to the y, I mean to the origin. And when you take 1, for example, f of 1 is 1, f of 1 equals 1, negative 1, f of negative 1 is negative 1. So f of negative 1 is the same as f of negative f of 1. So we have f of x, f of negative x is the negative of f of x. So that's odd. Linear function. It's f of x equals mx plus b. Mx plus b. So we can take just one example. Let me take 3. F of 3 equals 2, where is negative 3? Negative 3, f of negative 3 is not f of 3, it's not f of negative, negative f of 3. F of negative 3 is negative 1. So not 2, which will make it closer to a conclusion that this function would be even. And it's not negative 2, which would make it closer to a conclusion that this function is odd. So then that's going to be neither. Linear function is neither. Constant. It's f of x equals a, where a is real number. So let me take x equals negative 3. It's 2, right? X equals positive 3. Same. And we can do that for any number. It will be the same. So f of negative x equals f of x. Constant function or functions are even. Cube root function, that's f of x equals cube root of x. Well, 1 is 1, negative 1 is negative 1, and it would work for any value. So f of negative x is negative f of x. This is odd, and also we can see the symmetry with respect to the origin here. So that's odd function. Next, now we will try to sketch a graph of functions that are given in piecewise. Piecewise functions are functions that are defined in different parts of the set of real numbers. So piecewise function are functions defining differently. Piecewise functions are defined differently on specific parts of the real number. Differently on different parts of the set of real numbers. Now, what I'm trying to show you is, like, you see how for this part of the real numbers, you get f of x that is negative 2x minus 1. And then when you take this part, for x greater than 0 or 0, and then you have a different expression. And that could have been any other things, but both of them are linear. So I'm going to try to identify how I know that they would intersect. The two, 0 would be the common point. The only difference is that at 0, this function will take an open circle because it's not included. And at 0, this expression, when I'm graphing it, will take a closed circle. But 0 would be the common point between the two. So let me try to see how they behave in 0, both of them. First, we identify how they behave in 0 or this bounds. So first, to graph them, find out how each part behaves at the bounds. So the bounds would be the limit of the intervals. So for x, here for x equals 0, then that will be your y-intercept. So the y-intercept will not be included. So I'm going to put a 0, an open circle here. Open circle here. X equals -1. That's the y-intercept, but it's an open circle. For this second part, at 0, it's going to be 2. But because it has greater or equal, then I'm going to keep a closed circle. So let me use a different color, 2. Close. Now, next, since there are lines, if they were not lines, I would find points to see the pattern of each of them. But since there are lines, I'm going to find the slope to see from this point, how do we go and how this one, each one would what the pattern of each one of them. But we need to pay attention. The blue, that's the blue here. This is my blue, and this is my pink. The blue is on the right side of x, right? On the right side. And then the slope equals 3, or just, as you know, 3 over 1, right? That means from here, you're gonna go up, 3 and over 1. 1, 2, 3 and over 1. That gives me another point, and then that's good because I can just draw this line all the way through on the right side of the x, because it's the positive side. That's x greater or equal to 0, because the closed circle, that's why I put equal. Well, let me just put greater than 0, and that's x greater than 0. That's why all the numbers are positive. And then for x less than 0, the slope is -2. That means I'm gonna go down 2, 1, 2, and over to the left 1. I mean, no. Down 2. Down 2, 1, 2, and then over to the right 1, right? But I'm not going to keep it on the side. So I'm gonna try to see how it's going to the side, this side. Let me go inverse, because when you have -2 over 1, it's the same as positive 2 over -1, right? So for this one, you would say rise down, and then this one will be run left, run right. But since I give the negative sign down to the bottom here, so I'm going to reverse it. I'm going to rise up and then run left. So let me go rise up 2, 1, 2, and then over left. That's another point that I can just continue. I don't want this part, right? So this part will be in the positive side, so I don't want it. So that's why I'm going to remove it here to keep it at the start point 0. And then keep this on this side because it should be extended only on the negative side of the axis of the x-axis, that's x less than 0. So our next example here, oh, well, we're not done yet. What's the range of this? The range would be from the bottom number, right? The bottom number here is -1, but it's not included. Oops. The bottom number is -1, but it's not included because it's an open circle. So it's going to be, the range would be from -1 to positive infinity because it goes on forever. And f of 0, well, we can see how we have 0 in both of them, but we're just going to keep where it has a closed circle only. So f of 0 would be where you have the closed circle, that is 2. Or x equals 0, you're not going to go here because it's not counted, but you can go up here to get the y value for x equals 0. Or you can go to the bottom, the one in the one where you have the equal sign, and then plug in the value 0 for x. So f of 0 equals 3 times 0 plus 2. So that is 2. Can either use the graph or do the algebra part of it. So now when you have the function that is in piecewise format, you need to pay attention whenever they ask you to calculate for a value. So you need to compare with the conditions they give you. So they want me to calculate f of -8. So that's x equals -8. X equals -8. So basically, I need to use the portion of interval that -8 belongs to. So -8 will be in this one. So I'm going to use this expression to find f of -8. So f of -8 would be 3 times -8 plus 5, right? Because that's the interval. -8 is found for the set of real numbers. So that's going to be -24 plus 5, and that's going to be -19. We need f of 0. F of 0, we need to select which, because 0 is included, and that's the expression that I need to use, the bottom one. So that's 2 times 0 minus 1 equals -1. So that's -19, -1. And then I also need f of 8. Where is 8? 8 is here. So I'm going to use this expression. So that's 2 times 8 minus 1, 16 minus 1, that's 15. So that is 15. That's it for module 2. I mean, that's it for topic 3.1.